let's start this. Since I have done about half of the chapter 6, we have to start from the C table. So question like this: to find the area, or given area, find the values, something like that, we have to use our C table. But remember that our C table only works with C table works with standard normal distribution. Standard normal distribution. Standard normal distribution. Okay, this is how I write the distribution in short form. Okay, what's that standard normal distribution? Which means perfect bell shape, means 0 and sigma equals 1. Okay, so C table uh, only based on the standard normal distribution. Whatever you have, let's say you have a normal distribution, then definitely you have to convert it to a standard normal distribution, and then you can use the C table. Okay, this is the way how we deal with C table. In this question, find the specific area. We need to find the area under the standard normal curve. So now we have standard normal curve. They are asking about standard normal curve. So question is area that lies between 0 and 0 and 3.01. So this is the uh, standard normal curve, and this is my 0. Okay, you can mark your 0 anywhere, it doesn't matter. And this is my 3.01. okay, so area is between 0 and 3.01, which means this area. So if I need to find this area, what should I do? I have to find the areas belongs to this from your from your left hand side to 0, and from your left hand side to 3.01, because I'll show you the C table. So in C table, every measures are taken from left hand side to right hand side. Okay, so everything starts from left to right. So you have to take the area from your left hand side to 0, and then you have to take the area from your left hand side to 3.01. Then you can take the difference. Area difference gives you this answer. Okay, then okay, C table is there. Value is 0. So how we find this area belongs to 0? If you have a value like your C value is negative, then you have to use this first table. Okay, you have to use this first table. In this first table, you can find the values which belongs to negative C values. Okay, these are the areas. These are the area values, area, and these are the C value. Okay, C value. So if your C value is negative value, then you can locate it from first table. See, everything measure from left hand side to left hand side up to C. Okay, but now I have my value 0. 0 you cannot find in this first table. See, there is no 0 in this C values. It's just 0, not negative 0. So if you use the second table, you can find the C value 0 here. See, 0. It is just 0. 0 means 0, 0, 0, whatever, or 0. Okay, same thing. So you can first locate first digit or digits before the decimal place, you can find from this C column, this C column. Okay, this C column. Digits before the decimal places. Digits after the decimal places, you can find from these columns. Clear? So 0, which means 0.00. So 0 is here, 0.0 is here. This value is, what is the area? The body gives you the area values. So area is 0.5. Then question number 13. Okay. So area belongs to 0 is 0.5. But you have to find the area belongs to 3.01 as well. Okay. So you can do the same thing, which means you can play the same game to find the 3.01. See, it is positive 3.01. So you can skip the table number 1, go to the other table, 3.01. Where is 3? First you have to find 3. Okay, this is the row belongs to C value 3. 3.01. 0.01 you have to find from these columns. 0, 1. It is this column. So come along with this column, you can find it is this value. Okay, 0.9987. Okay, 0. So area, which means from here to here 0.5, here to here, area is 0.9987. Okay, now you have to get the difference. This is 0.5, this is 0.9987. So now you can get the difference. 0.9987 minus 0.5. It's going to be 0.4987. Okay, that's how we deal with these kind of questions. Find the area in between, then you have to find the boundary values. Boundary areas belongs to this, like this. This is 0. So you have to find the area from negative, which means everything starts from this negative infinity and then from infinity. That's how it works, but you can just skip these infinity cases. Just remember, start from left hand side and from right hand side. Okay, so take this difference and find the area. Okay. If it is easy, since it is easy, they haven't mentioned anything like this. If you need to find the area which belongs to, let's say, I don't know values, let's say 2.0, I need to find the area belongs to 2.0, which means everything starts from left hand side to 2.0. So you can move to C table. It is a C value is 2.0. So first digit is 2. Locate the 2 from the C column, C row, and 2.0. 0 is the first column. So value is 0.9772. Got it? So our value is, this value is 0.99 something, I don't remember the value. Okay, that's how we deal with these areas. Okay, I can skip number 14 and let me check the 15. 15 is very similar to the previous one. See, they have mentioned you need to find the area, shaded area under the standard normal curve. So it is standard normal curve, don't worry. First find the area which belongs to this piece, which means area up to z value negative 1.08. So I'll call this area capital A. Okay, see these c values negative 1.08 and this value 1.08, same value but different signs. Standard, remember this, standard normal curve is symmetric. Symmetric about what? Symmetric about 0 or its mean. Mean is 0. Okay, so standard normal curve is symmetric about 0. So these values negative 1.08, positive 1.08, they are symmetric. Okay, so once you figure it out, area belongs to capital A, I mean this area, then it is similar to this area. Okay, so these are the easiest way to solve problems. Okay, if you know these properties, it is very easy to solve these kind of questions. So this question you can solve by using different ways. There are similar ways to solve this kind of question. Okay, I'll use the first technique which I told you by taking the difference. Okay, so you can find the area. Sorry, you can find, yes, you can find the area. I'll write steps here. Area belongs to C value negative 1.08. So let's find this area. Negative 1.08. This now C value is negative 1.08. So negative 1. Negative 1, not 0, 1, negative 1. It is there. See this row. Negative 1.08. Where is 08? See this column. This column. So go down this column and you can find the value. This row, this column, which means 0.1401. 1401. One four zero one. 1401. 0.1401, which means area belongs to this capital A is 0.1401. Again, you can find the area belongs to C positive 1.01. Area belongs to Z positive 1.08. Okay. Positive 1 point. Positive cases in this table too. 1.08. 1 is here. 0.8 here. So value is this 0.8599. 8599. 8599. Okay. Now you can get the area by taking the difference. 0.8599 minus 0.1401. It's going to be 0.7198. Okay. This is technique 1. Technique 2 is by taking the advantages of this symmetricity. Okay. Since this is symmetric, I told you this area belongs to C negative 1.08 equals to this area. Okay, area to the right of 1.08. Okay, so simply you know that a total area under this curve is 1. Total area under standard normal curve is 1. Okay, so you know this area is A and this area is A. Okay, so you can subtract these two areas from 1, which means 2 times A. Clear? So 1 minus what is 2 times A? A is area A 0.1401. Clear? Once you get these values, you will see that these two are similar. Clear? Those are the two ways you can find this answer. Okay, it doesn't matter either way, it works. So you can use one of these. Clear? Okay, let's move to question number 16. It's a little bit different. Still, we have to use the standard normal curve to find the C-score, which means your C value. Okay, having area. Now they have given the area. See, area is 0.09. They have given the area to its left. So I'll draw this picture for you. Area C-score, they have given C-score 0. Sorry, you need to find the C. Area they have given, I'll pick this area 0.09. You have to find this C value. Clear? So area given, need to find the C score. Previously what we did, given C score, find the area. Now given area, find the C score. So you have to use the same Z table. Okay, but now vice versa process. Okay, you know what's the area, 0.09. Okay, 0.09. Go to the C table. 0.09. Now you have to find the area from the body of this table. Okay, so you have to locate 0.09 from this body value. Okay, where is 0.09? 0.09 you can find from the table 1. 0.07. Okay, I can find two values, 0.0885, 0.0901. Okay, so there's a problem. I cannot find exact value 0.09, but I can find very close values 0.0885 and 0.0901. So in this case, you have to get a decision which value you should use. So always use the closest values. Always use the closest value. So I can see that my closest value for my value 0.09 is 0.0901. Okay, because the gap between 0.09 and 0.0901 is very small. So pick this, pick the raw value which belongs to this 0.0901. It is negative 1.3. Got it? Then get the column value. It's going to be 0.04. Okay, 0.04. So for a moment, just forget about this negative sign and add these two, which mean 1.34. Then put this negative value. Okay, this negative positive, they are just signs. Okay, so don't worry about the negative positive. Just forget about the negative sign and get the sum of these two values. Okay, clear? But don't forget this. Okay? Don't forget negative value when you put the answer. So answer is negative 3.5. sorry, negative 1.34. What's the question? Okay, so the C value is, let me erase this one. The C value is C equals negative 3 point, sorry, negative 1.34, which means this one. Okay, this is how we deals with if we have been given an area. Okay, okay. Number 16, then 17 is very similar to 16. What is number 8? Question number 18. Let's check question number 18. Table of areas is the standard normal curve. Okay, in the exam you don't need to find your C table. C table you can find just under those questions. Okay, see in this click here to view page 1 to, you can just click and get the C table. Okay, in this PDF I just remove those C table, otherwise this is going to be like 100 pages. Okay, that's why I remove the C table, but in the exam you can find the C table easily just below the question. Okay, find the C score. Okay, again find the C score. Area 0.86. Okay, there is another notation in this question. Area, sorry, C score having area 0.86 is equals to this notation. C value, which means C 0.86 subscript. C 0.86 subscript. Okay, so this is the notation to define an area which belongs to particular C value. Okay, C score having area you can define using like this: C 0.86, C subscript 0.86 mean C value which belongs to area 0.86. Okay, this is if you read it, this is how we denote it. Okay, so these are same. So this what they have mentioned and this what they have mentioned same, but don't forget this part. It's right under the standard normal curve. So if you use this notation, which means you always measure your area to its right. To its right. This is your C 0.86. Okay. If you use this notation, definitely it says that your area to its right. Okay. To its right always. So if you use this notation, or they have mentioned here C score having area 0.86 to its right, which means this area is 0.86. So you have to find this C value. Okay, so how do we find the C value? Total area under this curve, under the standard curve, is 1. Okay, so you can find this area, let's say area capital A equals total is 1 minus this given area 0.86. Okay, 0.86, 1 minus 0.86, which means 0.14. Okay, now you know the area belongs to A is 0.14. Go to the C table, find the C value which belongs to area 0.14. 0.14. So C value for area 0.14 is equals to, if you go to the table, okay, I'll show you 0.14, area 0.14, 0.14, 0.14 you can find from the table 1. This is 0.4, 1 is here, 1, 4, 1, 2 is here, 1, 4 here. See, you can see 0.14. Okay. Closest value is 0.1401. So what is the area? What is this related column? Related area? Related row? It is negative 1.0, and related column is 0.08. So 1.0 and 0.08. So this is going to be 1.08, but don't forget this negative sign. So answer is negative 1.08. Answer is negative 1.08. We are talking about question 8. Yes. So answer is, sorry, answer is C value for area 0.1414 is negative 1.08. This is the answer. Okay. This is how we deal with given areas. Okay, if you have to find the C score according to the given area, you have to deal with this. Remember that you cannot find the area C value belongs to given area to its right. Okay, you cannot find directly what is your C score by using this to its right. Okay, definitely you have to find the area to its left, because your C table, all values are given according to the left to right. Okay. Okay, number 19 is pretty close to that one. Let me do this question number 20. 20 little bit different, but the same method you have to use. Question number 20. I think you know now, you know how to find the value from the C table, so I'm not going to use the C table. I mean, I'm not going to show you this C table and find the value. I just pick the value from the C table and do the question. Okay. If you want, or if you need more regarding to C table, you can find my notes. There are two documents. I have clearly mentioned how to use C tables. Okay, you can find it on the blackboard. Okay, use C table of areas of the standard normal curve to determine the two C scores. Okay, there are two C scores that divide the area under the standard normal curve into the middle 0.874 area and two outside this area. Okay, this is the story they have mentioned. They have mentioned middle area 0 point this area. Okay, this area is, let me call it this, 0.874. This area is 0.874 and two outside area. Yes, there are outside areas this much. Two outside areas 0.063. Okay, 0.063 each. Okay, don't confuse with this. Okay, if you are confusing with this, I'll draw like this. Okay, this is each 0.063, 0.063. Okay, so now what you can do, it is easy. What you need to find, you have to find C value which belongs to here and here. Okay, you need to find these C values. That's a goal. So if you need to find this C value, first C value, what you have to do? You have to find the area from left hand side to this point. So you know that value. Area is 0.063. So go to the C table and find the C value with respect to this area 0.063. So C value, for area 0.063 is negative 1.53. Okay, that C value is negative 1.53. I think you can find that value using the C table. Okay, so now what? Now you can find the area. You can find the area from your left hand side to this point. How you find that? 0.060 is this much, and the given area is 0.874. So add those two together, you can find the total area from your left hand side to this point. Okay, so C value for area, I'll write here the area 0.063 plus 0.874. Okay, okay, this is going to be 0.937. Okay, so area C value belongs to area 0.937. You can find the C table. It should be definitely it's going to be a positive value. Okay, you have to look at the second C table. This value is going to be 1.53, positive 1.53. Okay, so these are the two C values, negative 1.53, positive 1.53. Okay, so everything you have to play with these areas and C values. Okay. Okay. Question number 21 is a little bit interesting. Variable X is normal distributed. Variable X is normal distributed, so you don't have to worry about that. But just normal distributed. Okay, normal distributed only. They haven't mentioned anything about standard normal distribution. Okay. So you should know, since this is normal distributed, you have to convert this into a standard normal distribution and do your calculations. Okay, so they have mentioned the mean is this much 60 and the standard deviation 4. Find probability of x less than 53. So x is what? X is normal distribution. It's normal distributed. So you have to convert your x into standard normal distribution. Standard normal distributed variable we denote by C. Okay, C. So how we use this? Do you remember there was a equation C equal x minus mu divided by sigma. Okay, you have to exactly use this formula to find this P. So you can convert your x to C by using x minus mu divided by sigma. Same thing you have to do for your value. Mean 60, standard deviation is 4. So your value is 53. So 53 minus mu divided by sigma, which means 53 minus 60 divided by 4. This is going to be negative 7/4, which means negative 1, 3 mean 8, no, 7, 2, 5, 7, 5, negative 1.75, this area. Okay, so what now? Now you have to, you know what is the area. You have to go to the C table and find the C value. So C value belongs to area negative 1.75 is, if I'm correct, it's going to be 0.041401. Okay, so by using general notation, you can find this like probability of x less than 53. This is what you need to find. So you can write it x, you can convert into a standard normal values, x minus mu divided by sigma, and still you have this less than 53. Same thing you have to do, this value minus mu divided by sigma. Okay, same thing what I've done above. So again you can write this. So this gonna be, this first piece is gonna be C. Okay, so C less than 53 minus mu, which mean 53 minus 60 divided by 4, this one. Okay, so this gives you z less than negative 1.75. So this is what you need to find, probability of z less than negative 1.75. Okay, sorry, this is the C value. Okay, I'm sorry if I think I missed it. This is going to be a C value, so you have to find the area. Okay, sorry, yeah, C, you have to find the C value. Sorry, you have to find the area. Sorry, let me write this. Sorry. Area belongs to C value equals negative 1.75 is, oh, it's given. Okay, I have already written it here. To C, area belongs to C negative 1.75 is this much. Okay, so here this is a probability value, so which means this is an area. Okay, I told you probability equals area. Clear? This value. Okay, if you convert it like this, then you will get the C value like here negative 1.75. Then go to C table, locate the negative 1.75 and get the area. Okay, okay, if you want you can practice with these notations as well. Okay, these are the general notations which we are using to solve these kind of problems. Okay, it doesn't matter which notations you use, because you have these multiple choice questions, so no problem with that. Okay, okay, let me go through question number 22 real quick. Rates application for credit normal distributed. Okay, just normal distribution with mean and given standard deviation. Okay, normal distributed. So I'll use my second notation I use here, this one. Okay, it is very easy to solve this kind of question. Find the probability rating is between this much. Okay, they ask, okay, they have this much, this normal distributed values 200, 275. So they need the area between these two. Okay, so you have to convert. This is by using C x minus mu divided by z sigma. Then it's gonna be just perfect bell shape. You will be having two values, and you can find the area. That area is exactly same to this area. Okay, so how we do it? Let's convert these values. Okay, convert these values. So to don't have enough space. Okay, anyway, x minus mu, 200 minus mu, mean is only also 200 divided by sigma is 50. It doesn't matter, this value is 0. Okay, the next value, this value belongs to here, it is 0. Okay, the other value, x is 275 now, minus 200, it is the mean divided by sigma 50. So this is going to be 75 divided by 50. It is 1.5. So this value here, C value here is 1.5. Now you know what to do, right? Find the area between these two values, 0 and 1.5. Okay. You know, already know the area belongs to 0 is 0.5. Okay, we found it in question number 13, I guess. Area belongs to C0 is 0.5. Area belongs to C value 1.5 is I think 0.90 something. So you can find the answer this by taking the difference. Okay, so okay, I'll come to this area for C value 0 is 0.5. Area for C value 1.5 is I think 0.9332. So now you can find the difference, 0.9332 minus 0.5, it could be 0.4332. Okay, clear? So question number 23 same as the 22. Okay, let me check this 24. Why 24 is different? Okay, okay, it is different. Yeah, the lifetime of light bulb or bright bulb of a particular time are normal distributed, okay, with mean and standard deviation given. Okay, find the first quartile. Okay, what is the first quartile? Q1. Q1 is the first 25 from your data set. If you have your data set like this, Q1 mean first 25% from your data. Clear? Q1. This is Q1. Okay. Okay, that's the only thing you have to do with the Q1 quartile. So you know this is 25%, first 25%, which means your data set is now is this one, your standard normal curve, your normal curve. So it is 25%, 25%, this 25%, which means area 0.25, area 0.25. Okay. So again, this is just normal distributed. So you have to convert it to standard normal. You can find this value by using x minus mu divided by sigma. X is what? 0.25. Okay, 0.25. First quartile. So this C is 0.25. Okay, your data set first 25, that point is your Q1. So this point is 0.25, 25%, 0.25. So this now your Z value is 0.25. So X is 0. That X value you have to find. So how we find that one? Since this is your area, okay, since this is 0.25 is your area, go to the C table, find the C value which belongs to area 0.25. Area will, okay, I'll use this space as well. Area belongs to C, sorry, not area. We have the area, so we have to find the, yes, my yes. Okay. We have to find the C value. Belongs to area 0.25. So go to the C table, find the C value. It's going to be negative 0.67. This is a C value. Okay, this is C value. So this C value is negative 0.67. Now you have your X. Okay, negative 0.67. So X equals negative 0.67. Negative 0.67 minus mu. 318 divided by 8. Okay. Okay. Hold on. Okay. This is your C value. Okay. Don't confuse. This is your C value. Okay. We need to find what's the find the first quartile Q1, round your answer to 2 decimal places as you need. Okay. What is this? I need more space. So okay, I'll use these spaces. So C equals X minus mu divided by sigma. Okay. So you found C value. You found C value. It is this negative 0.67. But what they ask, first quartile. Okay, first quartile from the normal distributed case. Okay, so you found C1. It doesn't matter. First quartile from the because they haven't mentioned what is that first quartile Q1, which means you have to consider this first quartile from the standard normal distribution. Okay, standard normal distribution. Then find the corresponding Z value. So the C value is negative 0.67. Equation, you use X minus mu divided by sigma. So this C value gives you from this. So now you have to find this X because you know what is mu, you know what is sigma, you know what is C. So only unknown term is X. So simply you can isolate X by using a simple calculation. So it becomes X equals mu plus Z sigma, right? Mu plus C sigma, I guess. Yeah. Okay. So you know what is Z, you know what is mu, you know what is sigma. Plug those values and find the X. So mu is given, it is given 8, sorry, mu is 318 plus, you know what is Z value, it is negative 0.67 times sigma. Sigma is 8. So once you solve this, uh, you will get this answer 312.64. Okay. Okay. This is for question number 24. Okay. Since I go down, I messed with this question 25. Don't mess with this. This is how you exactly solve this problem. They have mentioned this is normal distributed case, mean given, standard normal, standard deviation given. Find the first quartile. So find the first quartile C value from your standard normal distribution. Okay. So you know first quartile mean 25%. So area is 25%, which means 0.25. Find the C value, which belongs to area 0.25. Then use this formula C equal X minus mu divided by sigma. You know what is mu, you know what is sigma. Now you know what is C as well. So only unknown term is X. Okay, Only unknown term is x. So isolate x, plug the values and find the x. That is your first quartile value. Okay. So those are quartile values. Let me go through the question number 27. It is easy. Okay. 27 is really easy. Five students are under consideration on the following. Following is the dot plot. Okay, dot plot. Sample distribution of the sample mean for sample size 2. Okay, what they ask, find the probability expressed as a percent. Okay, as a percentage, you need to find the answer. Sample within 2 points. Okay, this is the important part. Within 2 points of the population mean. Within 2 points. What is the population mean? Mu. Okay, population mean we denote by mu. Within 2 points, which means this one or this one, this one or this one. Okay, clear? That's the within 2 point. So how many points are there? 4 points. Okay, there are 4 points. So what's the percentage? 40. Percentage is 40. Clear? How? Because why? How many points are there? There are 10 points. Okay, there are 10 points. So within 2 points we have 4 points. Altogether we have 10 points multiplied by 100 to find the percentage. So it's going to be 40%. Okay, clear? Or 0, this is just 0.5, 0.4, probability 0.4, convert it to a percentage multiplied by 100, just 40. Okay. Okay, there is another type of question. 29. Okay, just before I go through this, there is something. These questions starting from I guess 27. These are chapter 7 questions. Okay, in chapter 7 we are talking about sample distributions. Okay, because sometime we will be having errors just by taking one sample. We will be having errors. To overcome that, we try to take few samples and find the mean and standard deviation of those samples. Okay, so that we can reduce the errors. When we increase the sample size, then error goes down. Okay, when we increase the sample size, errors goes down. Okay, so sample mean exactly equals to sample mean we denote by mu x bar. This is exactly equal to mu. Mu mean population mean. Okay, sample standard deviation, I'll write STD deviation. Okay, this we denote by sigma x bar. This is equals to sigma, which is population standard deviation, divided by square root of sample size. Okay, so whenever they have mentioned population mean and population standard deviation, easily you can find the sample mean and sample standard deviation. Especially sample mean, it is exactly same as the population mean. Okay, so they have given record indicate it has mean. Okay, it has mean 90 and standard deviation 40. Suppose snowfalls are sample unit randomly pick years. Okay, sample size given 49. Standard find the mean and standard deviation of x. Okay, we need to find the mean and standard deviation of x. Simply use this mean. Simply you can find it mu x bar equals mu, which means 90. Standard deviation sigma x bar equals sigma over square root of n. What is sigma here? Sigma mean standard deviation, it is 14 divided by sample size 49 is square root of 49, which means 14 divided by 7 is 2. Okay, so mu is 90, standard deviation is sigma x bar is 2. Okay, okay. So question number yes, 31, 32 are same. Okay. Okay. Just check 32. I'm not going to solve the question, solve this problem, but I'll tell you there is a special case. X is see X is a random variable with mean this much and standard deviation this much. They haven't mentioned X is normal distributed. Okay, X is normal distributed. They haven't mentioned, just random variable. Okay, X bar denoted by the dice all 32 times. Your n is 32 sample size. Distribution X is normally or approximately normal. Determine whether the distribution X is normally or approximately normal and find the mean and standard deviation. Determine whether the distribution of X bar is normally or approximately normal. Okay, and find the standard deviation of X bar. Okay, so there is few things I should tell you. If they haven't mentioned the population is normal distributed, you cannot simply consider your sample X bar is normal distributed. Okay, there are only two cases. If your sample is large enough mean greater than 30. For now, just remember that sample size is greater than 30. Okay, sample size greater than 30, which means large enough, so that regardless of the distribution, population distribution, you can consider your sample variable is normal, your sample is simply normal distributed, and do your calculation like using this what we have done. And also uh, distribution is normal distributed, then it doesn't matter your sample is also normal distributed. Okay, so no problem with that. In any case, they haven't mentioned your population is normal distributed, which means sample your population is not normal distributed and sample size is less than 30. You cannot assume that your sample is normal distributed. Okay, so if your population is normal distributed, then without any problem you can consider your sample is normal distributed. No problem, you can consider normal distributed. In any case, if yours they haven't mentioned anything about the population, which means population is not normal distributed, but your sample size is large enough, which means the sample size is greater than 30, then you can say X is approximately normal. Okay, which means you can say not just normal, approximately normal. You can approximate that. Okay, your X bar is approximately normal. Okay, so in this case you can see that X is random variable. They haven't mentioned it is normal distributed or not, but sample size is 30, which means 32, which means greater than 30. So you can say, okay, your sample your X bar is approximately normal. See, approximately normal. Okay, you can find the mean. It is since it is approximately normal, mu X bar equal mu. Okay, mu X bar equal mu. It doesn't matter. So which means 3.5. And you can find the sigma X bar, sigma divided by square root of n. N is 32. Sigma is given 1.71. So solve it, you can find this. Okay, that's about chapter 7. I think last few pages you can find the find this idea. Okay, last few pages of your chapter 7 note. Please have a look. Okay, I'll go to next question. This is going to be my last question. There are under the density curve that lies to the right, this much is this. Okay, this is 33. Okay, I have space, so I can, okay, I can draw it. Uh, Density curve to the right of 50, which means here it is 50. To the right, this area is 0.482. What percentage of all possible observation of the variable are at most? Remember, at most 50 mean maximum value is 50, whatever less than 50. Okay. Okay. You need to find what percentage, which means simply you have to find the area, right? So you don't need to go to the C table or whatever, just find the area. How we find the area? You know how to find this. Total under the density curve is 1. Okay. So 1 minus 0.482. It is 0.518. This is the area from left to 50, 50, because at most 50. So percentage, simply multiply this by 100%. So it's going to be 51.8%. Okay. So it is easy. I think the 7, yeah. Next question is the similar. It's a similar one. So this is how we deal with these questions. Let me show you. Let me go to the chapter 7 and show you what we have to do actually. Chapter 7, you don't have to worry about errors right now. So this is something like, see, this is a one example. Okay, let me, okay. This is a one sample. This is another sample. They have different sizes. See, okay. So how you get x bar in this case? You have A is equal to 76, B 78 divided by 2. Take the average. It is the 77. Likewise, different sample, they have different x bars. So if you take 2, which means according to this table, you can draw this dot plot. In this case, they have mentioned 1 sample, collecting of 2 sample, 3 sample, 4 sample. You can see that sample mean, which mean mu x bar converge into mu. Converges to mu. Okay, it's converged to one value. That is the population. Here they have mentioned population mean. Okay, sample distribution of the sample mean. Okay, what else I have to see? This one, mu x bar equals mu. Okay, mean of the sample means equals to mean of the population. Okay, this is the standard deviation. I'm not going to, okay, this one. This is since we have this giant theorem, this is we call central limit theorem, simply we call CLT. Since we have this, we can approximate our distributions to normal and something like that. This is the theorem I used to solve question number, I think 28, 29, something, if I remember correct. For relatively large sample sizes, the variable x bar, which means sample, is approximately normally distributed regardless of the distribution of the variable. Okay, approximation becomes better with increasing the sample size. If you increase the sample size, it becomes much better. Okay, by using this theorem. Okay, see, this is the properties I told you. X bar equals the population mean. You know that standard deviation is sigma over square root of n. If x is normal distributed, your population is normal distributed, then x bar regardless of the sample size, it is normal distributed as well. Okay, if the sample size is large enough, x bar is approximately normal distributed regardless of the distribution of x. It doesn't matter what's the distribution. If your sample is large enough, then x bar is not normal distributed, approximately normal distributed. Okay, so keep that in your mind. Although it is x bar is normal distributed or x bar is approximately normal distributed, you have to treat it as a normal distributed. Okay. Okay. I think that's the end of this